Hello, this is Jonathan Bukhara for Fluent C++. Today we're going to talk about metaclasses. Metaclasses are a proposal made by Herb Sutter a couple of months ago, and it made a buzz across the C++ community. It's a proposal that's worth looking into because it shows the structure of the language even as of today and in the direction we want it to take. So let's learn more about that. If you want to define a type, you've got essentially two options today, either struct or class. As we've seen in a previous video, how to choose between a struct and a class comes down to convention about what information you want to express about your type. But the thing is, since it's just a convention, there's nothing to enforce it in your code. So that's one limitation of struct and class. The second limitation is that in some cases, neither one really fits. Imagine the case of an interface, for example, like that type with several pure virtual methods and a virtual destructor and no data member. Well, what should we use, struct or class? There's nothing private which suggests maybe we should use a struct, but on the other hand, it can do things, it has responsibilities, so maybe it's a class. So in this case, for example, neither struct nor class really fits. That's the second limitation with struct and class. The last one is that it leads to duplicated code. Let's take the interface again. Actually, it's quite a canonical example with metaclasses. This pattern of having only pure virtual methods and a virtual destructor and no data and only public methods, this pattern is duplicated over and over in your code every time you create an interface. This leads to code duplication with the risk of forgetting the virtual destructor, for example. Metaclasses expand the way to create a type beyond struct and class. You can actually define your own metaclass, which is a type of type that allows to define a type. So, to make it clearer, a class describes what an object looks like, and a class is used at runtime to instantiate objects. Well, a metaclass describes what a class looks like and is used at compile time to instantiate a class. Now the question is, what's inside the code of the metaclass that describes a class? The metaclass proposal is based on two other proposals, reflection and compile time programming. Let's take the example of the interface we were talking about earlier. Reflection allows to access some data about the class, like are all the methods public, for example, and to manipulate this data, like if they are private, make them public, for example. And compile time programming makes checks at compile time, like is there any private member or is there any data member, which is not supposed to be the case in an interface. And after performing those checks at compile time programming allows to emit errors, compile errors, like an interface cannot have private data, for example. Compile time programming also allows to generate code, like generate a virtual destructor, for example. So we could define a metaclass interface with all those features, and then this interface would be used instead of struct or class to define an interface. And then we wouldn't have to write the virtual destructor and the equals 0 for the pure virtuals, because the metaclass would take care of that instead of us. That's roughly what's in the metaclass proposal. If you want to read more details about metaclasses, you can go check out the article on Fluent C++ that's called A Summary of the Metaclass Proposal. And if you have a bit of time ahead of you, then you can go check out the actual proposal. All the links are down below in the description. I hope this video has been useful to you. If you liked it, you can subscribe to the channel to get more about expressive code in C++. And if you liked it, you can share it with your friends and put a thumb up. Thanks, and I'll see you next time.